Hello. This time I'm going to be talking through AQA GCSE Maths 9 to 1 Foundation Tier, the Practice Set 2 lot of practice materials and the Paper 2 of that Practice Set 2. So Practice Set 2, Paper 2, which is a calculator paper. Let's have a look at the first question anyway. So we're asked, what is the probability of rolling a 5 on an ordinary fair dice? So on an ordinary fair dice, you should know that there's 6 sides and 6 possible numbers that can be rolled. The numbers that can be rolled are 1, 2, 3, 4, 5 and 6. 6 different numbers for the 6 different sides. So because we're interested in rolling a 5, we need to think about how many ways a dice can be rolled and it lands on a 5. So because only one of the sides has a 5 on it, the number of ways a 5 can be rolled is only 1 out of a total of the 6 possible sides it could roll onto. And so the probability of rolling a 5 on an ordinary fair dice is 1 over 6. And that's the answer to our first question. Question 2, which is not a unit of speed. That means kilometers per hour, this is miles per hour, meters per second, and this is kilometers. Kilometers is a unit of distance, not a unit of speed. And so we need to circle kilometers because kilometers isn't a unit of speed, it's just a unit of distance. Work out 81 as a power of 3. And so this is a calculator paper, luckily, and so what we can do is we can try all of these different options. So 3 cubed, let's see what that one is. So we get 3 on the calculator, press the power button, and press 3, and we get 27. So 3 cubed is 27, so it's definitely not that one. Let's have a look at 3 to the power 4. 3 to the power 4 equals 81. So that's what we need it to be. We wanted 81 as a power of 3. So 81 as a power of 3 is 3 to the power 4. We don't even need to bother trying any of these now because we've already got our correct answer. And so the one we need to circle is just 3 to the power 4. And we found it. Question 4. Which statement is true? Circle your answer. So again, what I'd suggest to do for this one is to use your calculator to its full potential and just work all these out separately. So the first one, we've got to work out 10% of 50. So percentage means out of 100. So 10% means 10 over 100 multiplied by 50, which is 5. And so this one here is 5. Now we can compare that with 50% of 20 using a calculator. 50% means 50 out of 100. 50% of 20 gives us 10. And so is 5 equal to 10? Obviously it's not, so it's not that statement which is true. The second one down, 10% of 10. Again, I'm going to assume you're using your calculator just to make sure with these ones. But in the same way, 10% of 10 would be only 1. 20% of 20, 20 over 100 multiplied by 20, that would be 4. So again, 1 doesn't equal 4, so it's not this one here. However, if you try this next one, 10% of 20, so again, I may as well just show you how to do it on a calculator. 10% of 20 equals 2. So this first one here equals 2. And this one, 20% of 10, we can work out in a similar way. In exactly the same way, actually, to be honest. 20% of 10 gives us 2. So does 2 equal 2? It certainly does. And so that's one we have to circle. So it says circle your answer. Be very clear to be circling this one. You're probably thinking, well, why has he circled all of these? It's just to illustrate for the purposes of showing you what each percentage of each total equals. So you wouldn't need to necessarily circle these in the exam, but if you were circling them, I suggest maybe do that in pencil and make it damn clear to the examiner with a big, clear circle the one you mean, which is this one. 10% of 20 equals 20% of 10. This one, the third one down, is the correct one. Question 5. This is a question of proportion. So we've got 15 rulers which cost £3. And we need to work out how much 40 would cost. So if 15 cost £3, what we could do to start off with is just work out the cost of one ruler. Once we work out the cost of one ruler, we can work out the cost of no matter how many we want to. And so how can I go from 15 rulers down to just one ruler? Now you might be thinking, well, I can just take away 14. But remember, with ratio and proportion, what we do to one side, we do to the other to keep the balance correct. So if we were to take away 14 on this side, we'd have to take away 14 over here. £3 take away 14. Would a ruler cost minus money? All I'm getting at is try to remember, by using a different example if need be, that with ratio we either multiply or divide each side by the same constant. So in this case it's not taking away 14. We need to be thinking, what number do we divide 15 by to get 1? The answer is any number divided by itself gives us 1. And so we divide this side by 15. If we divide this side by 15, we need to do the same to this side. And so 3 divided by 15, let's see what that would tell us. 3 divided by 15 is 0.2. That actually means not 2 pence, but 20 pence, because after the 2, you can consider there to be an invisible 0. But obviously we don't want just one ruler. We're asked here for how much 40 rulers cost. So to go from 1 ruler to 40 rulers, what do we need to multiply by? Well, 1 multiplied by 40 would get us to 40, and if we multiply this side by 40, we need to do the same over here to this value. And so we can calculate the cost of 40 rulers by doing 0.2, or 0.20 if you'd prefer, multiplied by 40, and what you should find is the answer to this is exactly 8. And so 40 rulers therefore will cost us £8. And that's our final answer for question 5. 40 rulers cost £8. £8 in standard English. Question 6. We have a bar chart showing that people in different age groups how they book their holidays. So I'm going to mention first of all, importantly, if you look at the y-axis, we're not actually told the numbers of people. All we're told is the percentages of the age groups booking either on computer, phone, agent in person, agent online. So just be careful not to mention the actual numbers of people, but the percentages of the age groups. Part A. We're asked which 2 ways of booking are most popular for 16 to 19-year-olds. And so be careful to look at the key properly. 16 to 29-year-olds is the lightest coloured bar. And so for 16 to 29-year-olds, they're just the first bars, the lightest ones. I'm just highlighting them here in yellow to make them even more obvious. And so for 16 to 29-year-olds, what 2 ways of booking are most popular? Well, for 16 to 29s, quite clearly, on a computer is by far the most popular for the 16 to 29s. So the first one is computer. That's the most popular way. And the second most popular, phone is the least, agent online is third, agent in person is slightly higher. So the second most popular for 16 to 29-year-olds is to use an agent in person. So 2 marks for getting both of those, 1 mark if you get one or the other. Part B, we're now asked what percentage of 16 to 29-year-olds booked with an agent. And so here we're just thinking about booking with an agent. It doesn't say agent in person or agent online, so it means in total. So 16 to 29-year-olds booking with an agent. We've got this one over here for the agent in person, and this bar over here for what percentage of them booked with an agent online. And so looking at the height of this bar, to me that would be 20%. And the height of this bar, again, if we were to just draw a straight line and compare it to the y-axis, so I'd imagine you'd use a ruler. I can do a crafty little cheat here of my lines, but same idea would apply. So the height of that bar, it's between 10 and 20, but it's definitely more than halfway between 10 and 20, so it's closer to 15. I would say that's about 17%. That's 15, 16, I'd say 17%. So 20% for agent in person and 17% for agent online. And so total means one added to the other. And so 20% plus 17% would come to a total of 37%. That would be 1 mark, but we've been asked to give our answer to the nearest 10%. So what we need to do is round 37 to the nearest 10. So 37 is closer to 40 than it is to 30. So to the nearest 10, that would be 40%. And that is our final answer for part B. To the nearest 10%, we've got 40%. 6C, we need to compare the bookings for 30 to 44-year-olds with the bookings for 45-year-olds and over. This one was 2 marks, so you need to make 2 valid comparisons. But fortunately, the comparisons can be more or less anything you like, as long as they're valid comparisons, they're true, and you use figures from the chart. So you can't just make things up or be non-specific. So let's have a look. So 45 years and over is the dark bar. In fact, that doesn't show up at all, so what we'll do there is just clear that off and try a different coloured pen. I'll try green. There we go. So we're looking at the black bars for 45 years and older. And we're comparing these black bars with the bars for the 30 to 44-year-olds. 30 to 44 are these ones which aren't light, aren't black, somewhere in the middle. So we're comparing the second and third bars for each group of bars. As I say, you're not limited in terms of what you want to say. You could say any 2 comparisons. So the ones I'm going to pick on, yours don't necessarily need to be the same as mine, but as long as yours are based on reality and are backed up with facts from the graph, you'll be okay. So the one I'm going to pick first of all is the computer one here. So based on the holiday bookings using a computer, we can see that the bar for 45-year-olds and over is higher than the bar for 30 to 44-year-olds. But don't say that means that more 45-year-olds booked on a computer than 30 to 44-year-olds. All we know is that a greater percentage of 45-year-olds and over booked on a computer. than 30 to 44-year-olds. And so the first thing I'd say is that a greater percentage of 45 plus year olds booked on a computer than the 30 to 44-year-olds. That's one valid comparison. That's 1 mark. So a second thing we could say is if you have a look at the phone sales, using the phone, a higher percentage of 45-year-olds and over books on the phone compared to the 30 to 44-year-olds. So similar wording to question 1 to keep it simple. Just do the same for point 2. Not question 1, I mean point 1. So point 2 we can say similarly, a greater percentage of 45 and over, 45 plus years, booked over the phone than the 30 to 44-year-olds. So that's 2 valid comparisons. That would get me 2 marks. If you wanted to, you could have compared agent in person or agent online, or just agents in general. So there you go, that would do for part C of question 6. Question 7, we're told that Sam spends exactly £20 on petrol and it costs £1.45 per litre. We need to work out the number of litres of petrol she buys and to give our answer to 1 decimal place. So what we can do for this one is one of 2 different options. So if you bear with me as you listen to this one, if the first way I explain it doesn't make enough sense to you, I'll explain it in a second way afterwards. What I'm going to mention first of all, using the first method, is to draw your attention to the fact that petrol costs £1.45 per litre. So that means for 1 litre of petrol, it would cost £1.45. This gives us a relationship between litres of petrol and the cost of that petrol. And this is also a relationship between 2 different units in the form 1 to n. What I mean by that is, because one of the numbers is a 1, in this case the litre number, and the other number isn't 1, if a ratio is given in this form, we can always change from one side to the other by multiplying or dividing by the number that isn't 1. So the number that isn't 1 in this case is 1.45. So to change from litres to the cost, we're going from a small number to a big number, so we'd multiply by 1.45. Going the other way around, from the cost to how many litres it would be, we'd take the cost and divide by 1.45. So that's just using the fact that 1 litre is £1.45, which the question tells us. What we want to do is to work out the number of litres of petrol she buys. And we're told that she spends £20 on petrol. And so we're wanting to change from the amount of money she spends to how many litres that would be. So from pounds to the litres she'd buy, the conversion here is to divide by 1.45. And so we can do this by putting in 20 divided by 1.45 and asking our calculator nicely for an answer. 20 divided by 1.45, 13.7931, and so on. Now, in this question, we're told to give the answer to one decimal place. And so what that means is we want to keep just one number after the decimal. We want to keep only that number after the decimal. So either it's going to be 13.7, or if it rounds up, it'll become 13.8. So how we decide is we look at the number next to the 7, which is the 9. Because 9 is 5 or higher, that makes this 7 round up to an 8. And so to one decimal place, we'd have 13.8 litres. I'll now explain it in a different way, as I promised I would. So if that one isn't making sense yet, bear with me. I'll just show you another way you could think about it. And so what we could do is set it out as £1.45 is 1 litre. Nothing new there, we're just using the same information. So I'm going to do it a different way now. What we could do is work out how much petrol she gets per pound. So what I want to do is to go from £1.45 down to exactly 1. So the question here is, what can I divide 1.45 by to get 1? As I hope you remember, if you take any number and divide it by itself, you will always get 1. And so what we do is divide the 1.45 by itself. That'll give us 1, which we want. But if we do it to that side, if we divide this side by 1.45, to keep the balance between the relationship, we need to do the same to the other. So we need to divide the right hand side by 1.45. And so 1 litre divided by 1.45, let's see what that tells us. 1 divided by 1.45, 0.689655, just a really long awkward number. Leave that on your calculator, would be my suggestion. So it's 0.68 something, I think it was, 689655, and so on. Don't round off yet, only round off at the very, very end. Now, of course, she didn't just spend £1. We've been told she spends exactly £20. So our next step would be to go from £1 to £20. And so what would we have to multiply £1 by to get £20? The answer, I hope you could see, is that we just do 1 and multiply it by 20. But like I mentioned before, what we do to one side, we need to do to the other. And so if we multiply the amount of money by 20, we need to do the same to the number of litres we've got. So if you took my advice and left that long awkward number on the calculator, we can just multiply this number by 20 now. And again, different method but same result. We'd get that for £20 to one decimal place, you'd get 13.8 litres. Different method. My opinion, not that my opinion needs to matter to you. The second method I've just shown is a bit more long-winded, but again, if it makes more sense, feel free to use it. £20 is 13.8 litres, and that's our answer, whether you use the first method or this second one in the corner. Question 8. I've given a spoiler away, calling it method A, so you probably know I'm going to mention more than one method. I'm going to mention two methods for this one. So we've got a diagram showing a triangle ACD and an equilateral triangle BCD. So that bit of information there is huge. It's an equilateral triangle. So what that means is that all the sides are exactly the same. So the length of this side the length of that side, and the length of the far side are all equal. So we can just mark these off if you'd like, just to remind you, these sides are equal. What you'll hopefully remember as well, that angles inside a triangle add up to 180 degrees. Equilateral triangle will mean that all sides are the same, and also all angles inside the triangle are also the same. So if there's 180 degrees inside a triangle, and these three angles here are all going to be equal because it's an equilateral triangle, we can find out the size of each angle by doing 180 divided by 3, which is 60. You may well have known that, or you may have remembered. Either way, that's just how you can prove it if you did forget. Each angle in this triangle will be 60 degrees. So whether we use this method or the next method I'll mention, we need to know that each angle in this equilateral triangle is 60 degrees. Now carrying on with this method, I'm just going to draw your attention to the other side of point B, which is over here. Now 60 degrees and this angle here touch together at B and are on a straight line. Angles that join at a point when on the same side of a straight line will add up to 180. And so these two over here will total 180. So the angle at B, angle ABC, will be 180 take away 60, which your calculator should tell you is 120 degrees. Now fortunately for you, it's not a proof question. It doesn't say show that or prove that. So you don't need to specifically state the angle facts you're using. So for this one, luckily you don't need to be saying angles on a straight line add up to 180 degrees, or angles in a triangle add up to 180 degrees. If you're not sure whether to say it or not, by all means do say it, but because it doesn't ask you to prove or to show that, just to work out, you don't need to worry about it in this case. Anyway, carrying on, let's just have a look at the left-hand triangle. So I'm going to just totally forget about this equilateral triangle now. So this one over here, I'm just going to erase, because using this method here, we're not concerned now by this triangle. We're just looking at the one I've got left. So this triangle here, we know two angles, so we can work out the third. Angles inside a triangle, angles inside a triangle will add up to 180 degrees. So x can be worked out by doing 180, take away 120, take away 40, which, if we try this in our calculator machine, we should find that x is 20 degrees. And please, whatever you do, do not measure angle x, because it does say not drawn accurately, so you're not going to get a guaranteed answer if you measure it. Not drawn accurately, so you can't just cheat your way to the answer by measuring the angle and putting the answer down. You need to work it out using angle calculations. So x is 20 degrees. I'm now going to show you the second method for question 8. So, like I mentioned in the first method, equilateral triangle means all sides are the same for this triangle. I'm not very good at drawing straight lines, luckily this helps me out. Equilateral triangle, as I mentioned in method A, all sides are equal, and also all angles are equal. So what you need to remember for any triangle, the sum of angles inside any triangle will add up to 180 degrees. So the size of each angle inside this equilateral triangle we can work out by doing 180 divided by 3, which is 60 degrees. Hopefully you know that anyway, but just in case you didn't, I'm just showing you how you could work it out if you're unsure. So which one of these is 60 degrees? Now what you might want to do is just consider the whole triangle from A to C to D. So don't even think about the fact it's been split down here. And so what we can do is just forget the triangle was split, forget this angle here, that's why I'm taking it away, and just look at the entire triangle. So this angle here is made up of a 40-degree bit and a 60-degree bit. And so the whole of the angle at C will be 40 plus 60, which would be 100 degrees. So the full angle at C will be the total of these little two angles that were there in the first place. So at C, we'll have a total of 100 degrees. We've also got this angle in the corner at D, which we worked out earlier was 60. So just using the big triangle now, we can work out what x is, because we know the other two angles in this triangle, 100 and 60. So x will be whatever's left. So angles in a triangle add up to 180. So x is going to be 180, take away 100, take away 60. And if we just check that on our calculator, you should find that the overall answer for the size of x is 20 degrees. I'll just show you here if you're doubting it. 180, take away 100, take away 60, equals 20. And so whichever method you use, you should hopefully find that angle A comes to 20 degrees. And that's your final answer for question 8. Question 9. We have a game made for a school fair, made by Jack. So players can win money by picking a win ticket from a tub. A player chooses a tub by picking a blue disc or a red disc out of a bag. So the blue tub, you can win £1 for picking a win ticket. For red tub, you can win £2 for picking a win ticket from that tub. So what we asked first of all is to complete the frequency tree. We're told that 400 people play the game and that 310 chose the blue tub. Now with frequency trees, what we need to remember is wherever the two things branch from, when we add up the totals of the things which branch, it will come to the total of what it branched from. And so 310 plus this one here will add up to 400, because 400 splits into these two values. And so first of all, we can work out how many people picked the red tub by simply doing 400 minus 310, which a calculator or otherwise you should get 90. So that's the first step I'd suggest. So 90 people picked the red tub. So we're told of those 90, 19 won £2. Like I mentioned before, the things that it branches into, the things that a number branches into need to add up to where these numbers branched from. So 19 plus this one here need to add up to 90. And so in the same way as we did the total, take away the other number for this yellow highlighted number here, we do the same for working out how many people must have lost. So the number of people that lost will be 90 minus 19. So 90 take away 19, we should get that that's 71. There we go, 71. So that's the second step. So we've got 90. We've now worked out the other one is 71. And looking at the top bit here, 310 people chose the blue tub. If 97 people won a pound, the other 310 take away 97 must have lost and not won anything at all. And so we can now work out the number of people who lost who picked the blue tub. So that'll be 310 take away 97. May as well use a calculator since it's a calculator paper. 310 take away 97, we should have 213, which we can fill in like so. And so, slightly harsh question only having 2 marks perhaps, but the 3 numbers you need to fill in are 90 down here, 71, and then 213. And that's how we complete the frequency tree. Part B, a player has 1 go at Jack's game, and we need to use a frequency tree to estimate the probability that the player wins some money. So what I'm going to do from part A is just fill in the values we had from before. So that was 90, that was 71, this one was 213. So I'm not giving away any new information, I'm just basically copying in what we got previously from part A, like I've shown you here. So we'll get on the case in a second. So if the question's asking to use this tree for the probability that the player wins some money. Notice how it says some money. So that's some money. It doesn't say if we win £1 or £2. So that can mean win anything. So that means win either £1 or £2. The question isn't stipulating whether it be £1 or £2. So the question doesn't care if it's 1 or 2. So the people that won some money are these 97 people that won £1 and these 19 people that won £2. So people who won money those 97 people plus 19 people that were lucky enough to win £2. So if you add together these two numbers, 97 plus 19, we should find that it comes to 116. So 116 people won something. So 116 people out of the 400 that played won something. Now probability can often be thought of as a fraction. So in this case, because 116 people out of 400 win some money, we can consider that as 116 out of 400. So we're using the relative frequency here to give us an estimate of the overall probability. So if 116 out of 400 people won some money, that's your best guess, that's your best estimate for the probability of winning some money for Jack's game. And so we can put this on our answer line, but it's 116 out of 400. If you want to, that can be simplified, but you don't need to worry so much with simplifying down fractions when it's a question about probability. If you want to, you can. So you could either leave it as 116 over 400, or if you'd prefer, you can simplify it down to 29 over 100. So if you feel more comfortable simplifying it down, by all means you can. And finally, for question 9, part C, Jack makes a profit of £25 from his game. We have to work out how much Jack charges players to have a go at his game. So we could do with defining what profit means, or how to work out profit. In simple terms, profit is just the difference between the money you take in, so money in, minus the money paid out. So the more money you bring in, the better. The less money you pay out for expenses, the better. So profit is the difference between money in and money going out. And so we can just work these out now. So how does Jack make money from this game? So money in is going to be from charging people to go at the game. So money in is going to be from tickets or from players. $400 people will pay 400 times for a game. So money out is money paid out in terms of winnings. So how much money does Jack pay out? Well, from part B and part A, just copying down what we had before, the numbers were 213, 71 and 90. So what we can see here is that 97 people won £1, and so he pays out £1 to 97 people, 97 multiplied by 1 if you like, and plus he also pays out £2 to 19 people, so that's 19 times 2. So the total amount of money Jack's paying out to people that have won his game is 97 multiplied by 1, which is just 97 if you'd like, plus 19 multiplied by 2. You don't need the brackets, but if you want to be comfortable, you can include them. That's £135. And so using this equation for profit, profit is money in, oops, use a different colour for that one, so money in, take away money going out. So we've just worked out now how much money Jack pays out. He pays £135 out in terms of prizes. We're also told what his profit actually was. His profit is £25. So we can put these numbers into this equation now. So the profit, which was £25, equals money in from 400 games. Just call it money in for now. We'll come to that in a second. Minus money paid out, which we've just worked out is 135. We can now make some headway in solving this. So we can rearrange this equation to work out how much money was brought in. Now your teacher might mention it differently to me. Whichever way you want to do it, you should get that the money in is 160. The way I personally think about it is that we want to have money in on its own, so we can get rid of that minus 135 by moving it to the other side of the equation. And when we swap the side of something, we swap its sign. That 135 is minus. When we swap it over, it becomes plus. So the money in will be 25 plus 135, 135 here, plus 25, 160. So £160 is the money that Jack brings in from people playing his games. So just taking this point down here to where we've got some more space, Money in is from 400 games, and so you must charge in total. There's 400 games in total. He's charged people £160 in total. So we want to work out how much he charges just for one game. Just for one go. So how can we go from 400 games down to just one game? What can we divide 400 by to arrive at 1 exactly? Well, any number divided by itself gives us 1. And so that tells us we can divide the 400 by 400. But to keep the balance, if we divide this side by 400, we need to do the same to the other number as well. So 160 divided by 400 will ultimately tell us the cost of each game. So 160 divided by 400 let's see, 2/5, 0.4. So in terms of money, not 4 pence. After that 4, consider there's an invisible 0 after it. So that would actually mean 40 pence. So the answer is either 0.40 or we could say 40p. So we have in pound notation 0.40 or in pennies 40p. And that's question 9 completed. Question 10, a question about a bakery, and it makes 480 pizzas and 2,400 rolls each day. That sounds an awful lot. Maybe it's Greg's, who knows. So in 1 hour, each baker can make 20 pizzas or 75 rolls. Each baker works for 8 hours a day. Work out the minimum number of bakers needed each day. What I suggest we do is be systematic and just divide up our thinking into the 2 main things. So we're talking about pizzas on one hand, on the other side we're talking about rolls. So let's just think about it in terms of pizzas and rolls. So, after we've done that, we can then consider how many bakers are needed for each pizzas and rolls. And so we're told that for 1 hour, each baker can make 20 pizzas. So one baker can make 20 in 1 hour. But we're told quite clearly, if we read it, that each baker works for 8 hours each day. And so if this baker can do 20 in 1 hour, then in 8 hours, assuming here that he can bake at the same rate, he or she can bake at the same rate, we can just multiply that by 8. 20 can be made in each hour, so it's 20 in each one of those 8 hours that the bakers work. And so 20 times 8 will be 160 in 8 hours. So 160 in 1 day's work, essentially. Of course, though, we want more than 160 pizzas. We're wanting 480. And so, if one baker can do 160 pizzas in 8 hours, how many bakers will we need? So we need to get to 480. So we can work out how many times 160 goes into 480 by either thinking, what do I need to multiply 160 by to get 480, or just by doing a straight division. 480 divided by 160 would be 3. So that tells us that if one baker can do 160, we need 3 bakers to do 480 in a day. So for the pizzas, we need 3 bakers. I'm just going to section off the answer before my writing gets out of hand and I invade the answer line. So 3 bakers can make 480 pizzas. So that's the pizzas sorted. But of course, this bakery isn't just about pizzas, it's also got its reputation to worry about for its rolls. So now we do the same idea for the rolls. So we're told that one baker can make 75 rolls in an hour. So again, how many could he make in a day? Or how many could she make in a day? So if one baker can make 75 in 1 hour, then in 8 hours, assuming they can work at the same rate, we can multiply that figure by 8. So 75 multiplied by 8 would give us a total number of 600. 600 in 8 hours. 8 hours is a full working day. So each baker can do 600 rolls in a day's work. But of course, we don't want 600. We're wanting here to have 2,400. So if one baker can do 600 in a day, how many bakers would we need to bake 2,400? What we need to do is compare the 600 to the 2,400. One baker's 600, add in another baker, that'd be 600, another 600, another 600. You'd need 4 bakers to do 2,400 rolls. And that could be calculated directly, if you'd want, by just doing a division of 2,400 divided by 600, which is 4. So if we need 4 times as many rolls, we'll need 4 times as many bakers to bake those rolls. 1 times 4 gives us 4. So we need 4 bakers for the 2,400 rolls we need. And so in total, the minimum number of bakers, we need 3 bakers for the pizzas, plus 4 bakers for the rolls. So 3 plus 4 tells us we need 7 bakers minimum. So our answer is 7 bakers each day. And that's part A done. We also need to have a look at part B now. So the bakery are going to make some changes. Maybe it's a restructure, I really don't know. So it says in an hour, each baker now makes 10% more pizzas or 20% more rolls. Pizzas are sold for £2.50 and rolls are sold for 8 pence. So the manager's done some calculations, which you can see here. We need to check his working, correct any mistakes, and write out the correct calculations below. And so 10% more pizzas. So we were told in part A about the pizzas. So pizzas for 1 hour was 20. 10% more, as you work this out correctly. So what's 10% of 20? Well, 10% of 20 would be 10 over 100 multiplied by 20. which is 2. So that seems okay. 10% more means an increase. 20 add 2 is 22. So as far as I can see, that looks absolutely fine. So I've checked that, that's okay. And so 10% more pizzas, we agree with him. So 20 plus 2 equals 22 pizzas. There's no problem with what's been put down there. The next one, sales of pizzas. 22 multiplied by £2.50. Let's see if he's got that calculation correct. 22 multiplied by £2.50 equals 55. So that also is okay. So we can confirm that that calculation is okay as well. So making rolls for 1 hour. Maybe he's made a mistake down here. 20% more rolls. So it was 75 rolls being made in 1 hour by each baker previously. So what's 20% more of 75? Well, 20% of 75 we can calculate by doing 20 over 100 multiplied by 75, which is 15. He's put in here 20, which is wrong. So we just need to circle that. That should be 15. So if we write out our corrections, 20% more rolls will be 75 plus the extra 15 on top. More means an increase. 75 plus 15 will be 90 rolls. So again, because he's put down 95, that's made this calculation wrong as well. It's not 95. It should be 90. Looks like he's making an awful lot of money from these rolls. £760. That's much more than the pizzas. £2.50 for a pizza, £8 for a bread roll. It better taste nice. £8, that's a lot of money. If you look here, he's taken the 8 pence and thought of it as £8, so that's why he's mildly out. So it's not 8p, so it is 8p, it's not £8. And so in a calculator, he shouldn't have done the 8 like this. In terms of pounds, he wants pounds coming out, so he needs to put pounds going into his calculation. 8p is 0.08. And so he should have multiplied by 0.08. And that would have affected this answer here. And so we can do this calculation for him. So the sales of rolls, there were 90 rolls. The cost per roll is 0.08. So if you multiply 0.08 by 90, or 90 multiplied by 0.08, what we'd have is 7.2, which means £7.20. So because he's got this part wrong, then this again is still wrong. So this final line needs correcting. So for total from sales, £55, which we agreed with, plus sales from the rolls, which is £7.20, definitely not 760. So type these in, 7.2, £7.20 plus 55. That tells us that the total of the sales will be 62.2, which means £62 and 20 pence. And that's question 10 done. Question 11 is about this square that's been cut into 2 equally sized rectangles. We need to tick a box to show whether each statement is true or false. So first of all, we mention about the area of the square. So is the area of this square 2 lots of the area of one rectangle? Area is just how much space is inside. Areas of space on the inside of a shape. And so if we have a look at these two here, these two have come from this square. And so if you see here, they fit exactly on top of the square. They're no bigger or smaller. The two rectangles are exactly the same. So no bit of paper has been cut away or thrown away. We've still got the same amount of space inside, and so the area will be the same. Two of those came from exactly one of those, and so we can tick that that's true. Perimeter, well, perimeter means on the outside. Perimeter is the length around the outside of a shape. And so for the square, the perimeter was just all the way around the outside, which you can imagine here for these two separate rectangles. So around the outside would be that. Then the scissors came and cut, and we also have this bit here. But because it's been cut into two extra edges have been made, and so each rectangle has also got an extra line here on it. So the perimeter of each rectangle is actually more when you combine the two. So two lots of the perimeter of one rectangle would be this yellow part doubled, which is the same as a square, but also we'd have two extra edges, which are represented by these two extra green lines. And so if you doubled the perimeter of one rectangle, you'd actually have a longer length. It'd be a bigger perimeter. And so this one here would actually be false. So I need to tick false. Third point, the longer side of one rectangle apparently is 2 times the shorter side of one rectangle. And so if we have a look at this one, the longest side of one rectangle is, just erase these for now so we can see what we need. So the longer side is either the top edge or bottom edge, depending on how you want to look at it. So that's the longer side. The shorter side of one rectangle will be, in this case, the width, which should be this line here. So that's one lot of the shorter side. 2 lots would be this here. 1 plus 2. But because the square was cut into 2 equal rectangles, this was cut in half. And so one here plus an extra one there would be the same as going all the way from one to the other. And because it's a square, 2 of those together will be the same as the top edge, because the sides of the square are all the same. And so this one plus that one, which was initially the green side of that square, will be the same as the yellow top edge, because sides of the square are equal. So that yellow bit is 2 lots of the shorter side of each rectangle. So that one is true. And finally, we've been told that the diagonal of a square is 2 lots of the diagonal of one rectangle. So let's see about this one. Diagonal of a square just means from end to end, from corner to opposite corner. So for the square, the diagonal length is this. Now, if we take the diagonal of one of these rectangles, it's going to get one rectangle here and the one there. So if we consider that to be doubled, 2 lots of the diagonal of one of the rectangles, Well, this is the length of one diagonal from corner to corner. Carry it on for the length of the second one. That's one diagonal of a rectangle, and that's another diagonal. Add them together, that's two lots of a diagonal of one of them. So would you say that this blue line is the same length as this red line? Well, it's not. If you measured it with a ruler, if you're unsure somehow, to me it looks obvious that this one's longer. So that's definitely false. The diagonal of a square isn't the same as that, because this one's longer. But if you're ever unsure, you could just measure with a ruler, and this red side here will be shorter than this blue side here. So if you're not sure, check with a ruler these two lengths. Now if you can't draw that on your exam paper, you could just do one lot of the diagonal of a rectangle, measure that and double it. It's the same as what I've got here for both of them. And so that final statement is false. That red line isn't the same as that big blue line. Part B, the perimeter of each rectangle is 24 centimetres. We need to work out the area of a square. So I'll just get one of these rectangles here. Now we need to remember something from part A, and that something is that this square was cut in half. And so this side is the same as this side, because this one's cut in half. This side here of a rectangle will only be half as long as this top edge. I'm going to show you two different ways of finding the length of this. The first way I'm going to show you is using algebra. So if I call that L for length, this will be L down here as well. Because this is only half as long, because it's been cut into two, this bit of a square, this will be half of whatever we're calling for L. That's only half as long. And this will be the same on the other side of a rectangle, because opposite sides of a rectangle are equal. And so the total perimeter in terms of L or X, whatever you want to call it, is L plus a half L plus another L plus another half an L. That's the perimeter, and we've been told that the perimeter of each rectangle is 24. So that'll be 24. We can simplify this left-hand side. L plus half an L plus L plus half an L. L plus L is two L's, and two halves make a whole. So half an L plus half an L is 1L, plus two whole L's will give us 3L. So 3 lots of the length of this rectangle equals 24. And so the length on its own I can get by getting rid of this 3. This 3 is multiplying L. So opposite of multiply, if I swap it to the other side, I'll swap the sign. Opposite of multiply is divide. So that will tell us that the length is 24 divided by 3, which is 8 centimetres. So the length equals 8. And the length of the rectangle is the same as the length of the square. And so now we know the length of the square is 8. I'm just going to mention how you could have arrived at the length being 8 via trial and error. So if I get a different one here, you know the perimeter needs to be 24. You could have just tried some numbers. Trial and error isn't a bad way of doing things here, because this is a whole number and it's even. So odds are, for a simplest shape like a rectangle, the numbers will also be quite easy to work with. So maybe it was 10. If that was 10, this would be 5. Try that. 10 plus 10 plus 5 plus 5 would be 30. If that's too big, it needs to be 24. So if you went lower and tried 9, nine, 9, 4.5, 4.5. If you add all those together, that would be 27, which is still too high. The fact it's a calculator paper makes trial and error strategies more viable, because the calculator can just help us speed through it. Eventually, anyway, you would find that 8, half of 8 is 4. That would work, because 8 plus 4 plus 8 plus 4, if you don't trust me, would be 24 like it needs to be. So anyway, the long and short of it is that the length of this square is 8. From there, the rest of it's fairly straightforward. If the length of the square is 8, the area of the square is just the length times the width. Now for a square, the length is the same as the width. So 8 times 8, 8 squared literally, would be 64. So the area of the square is 8 times 8, which is 64. And so that's what we put on our answer line. 64 centimetres squared for the area of a square. Question 12. We've been given a formula for the amount of tax you pay if you are in employment. So T stands for the tax you pay in pounds, and E stands for the amount you earn in pounds. So the first thing we've been asked to do here is to work out how much tax would you pay if you earned £20,000 in a year. And so for this question, we can just use our calculator, if needed, to substitute in the value, easy as. And so how much tax you'd pay would be T equals 0.2, open brackets. Now E is the amount earned. And so if E is the amount earned, and in this question we're saying earn 20,000, we can substitute in 20,000 for the value of E. Because E is, in this case, 20,000. Then minus 10,600. If you take the time and effort to invest and master a decent calculator, like this one here, I'm not saying this is the only good calculator, but it's very good. You can get it. It's a Casio FX83. What you can do is type it in exactly as it appears. So 0.2, open bracket, 20,000, too many zeros, minus 10600, close brackets. That tells us that you would pay £1,880 in tax. But the only thing we had to do there was just swap E for the value of E. We got 1,880. Now for part B, we're asked how much tax, what's the most money you could earn without paying tax? This is a 1-mark question, so it will likely be fairly quick. There'll be a quick way into it. Essentially, you need to earn over a certain amount before you're taxed. If you don't earn enough, it'd be unfair to tax you anything. You can't pay negative tax, however. Tax only has a meaning if it's a positive value. And so the idea is, what would E have to be so that this whole thing, T for tax, would be 0? And so what this here means is 0.2. There's nothing in between the 0.2 and the bracket telling us what to do, so it will always mean we're multiplying it. And so what would E have to be for this bracket to be equal to 0? Because any number multiplied by 0 would give us 0. So T would be 0 if we're not paying tax. And the answer to that is E would have to be 10,600, because 10,600 take away 10,600 would be 0. So above £10,600 you'd pay tax, but below that threshold no tax would be paid. Again, you can try it on your calculator if you're ever unsure. So 0.2, then brackets 10,600 minus 10,600 gives us 0, which is what we're after. Question 12c. This can be done by two different methods. You could do it algebraically. Also, you could do it using trial and error. So I'm going to show you, if nothing else, just to demonstrate the use of getting a decent calculator. I've tried this in a practice run without honestly knowing the value myself, just to show to you how easy it is. So Alison pays £5,200 in tax, and so what we're trying to do is find out what value of E would give us a value for the tax of £5,200. And so 5,200 equals 0.2, something take away 10,600. So we know from part A, whoops, one too far back, part A, we knew that 20,000 you'd pay £1,880 tax, and so if this person's paying 5,200, she must be earning more than that. And so what we're going to do now is try different values for E. And so 0.2, we could guess maybe 30,000. Again, take away 10,600. I'll show you the algebraic way, the understanding way after. I just want to demonstrate what this calculator is capable of. 30,000, take away 10,600. 3,880. We want the answer to be 5,200. That's too low. So go higher than 30,000. So you can just press backwards. Leave the equation as it is and just edit it to 40,000. 5,880, so that's too high. So 30,000 was too low, 40,000 was too high. Let's go back and try halfway in between. How about 3,500? Press delete one too many times. £35,000. 4,880, so that's quite close, but still a bit lower than 5,200. Let's go up £1,000. Let's try from 35 to 36. 5,080, getting closer. 37,000. It's a bit too high. So it's between 36 and 37,000. See how quick it is with a calculator if you know what you're doing. This isn't easy if you don't know what you're doing. I'm just demonstrating that with practice, it's well worth practicing how to use it, because you can do questions like this. So it's between 36 and 37, maybe 36,500. £20 too low. Let's go up another 100. Bingo. That gives us 5,200. So the value of E that works is 36,600. E must be 36,600. Now, I tried that question before recording with honestly no idea what the answer would be. 3 marks, so in an exam, that would take you about 3 or 4 minutes, you'd allow yourself. A minute per mark, roughly. I did that using the trial and error method of a calculator in about a minute. Now, obviously, I teach maths, but with practice you can get up to that speed as well. So 3 marks, 3 minutes, you could just do that using trial and improvement with a decent enough calculator. So the answer would be 36,600. But I'll show you how to do it with a bit of deeper understanding using algebra and equations. And so what we're saying here is that she pays £5,200 in tax. So here's a more standard method. So we can substitute in for values we know. So 5,200 equals 0.2. E is what we're trying to work out. We need to work out the earnings that give a tax of 5,200. Obviously we've worked it out using trial and error, but I'm going to show you now how you do it how you do it the old-fashioned, good old honest way. So with brackets, what I'm hoping you'll remember is that brackets can often be expanded, and so we can expand these brackets out. And so leave 5,200 as it is, but let's expand these brackets. And we expand brackets by multiplying what's on the outside by what's on the inside. So 0.2 multiplied by E would just be 0.2E. Got a minus sign, so put the minus sign down as well. Then 0.2 we're going to multiply by 10,600. So 0.2 multiplied by 10,600 will be 2,120. We want to rearrange the equation so we've got E equals whatever it equals. So at the minute we've got 0.2 in the way and this minus 2120. So what we could do is rearrange this equation by adding 2120 to both sides. What it looks like is happening is we can move that 2120 to the other side of the equation, but when we swap the side, we swap the sign. Opposite of minus is plus. So after we move across this 2,120, on the other side we'll have 5,200 plus 2,120, which is 7,320. So 7,320 equals 0.2e. Finally, we don't want 0.2e, we want to have just e on its own. And so we want to get rid of this 0.2. And in the same way as before, we can swap the side and swap the sign of the thing we want to get rid of. That 0.2 is multiplying the e because it's right next to it. So when it swaps over, opposite of multiplying is dividing. And so e will be 7320 divided by 0.2. So 7320 divided by 0.2, we get 36,600. So therefore, the earnings for Alison's earnings must be £36,600. Question 13. We need to be circling the number which has been written in standard form. Now, a number in standard form will always look the same way. Just to refresh your memories, a number in standard form will look like a times 10 to the power n. And n is an integer. What that means is n is a whole number that can be negative. So -1, -2, 1, 2, 3, 4. So it's a whole number that can be negative, and A is somewhere between 1. A can be 1, but A absolutely must be less than 10. So A is between 1 and 10, and times 10 to the power n, where that's a whole number. And so the first bit of a number in standard form needs to be between 1 and 10. This one here, 0.5, is less than 1. That's not between 1 and 10. So it can't be that one. This one over here, 50, isn't between 1 and 10. It's more than 10, so it's not this one over here either. This one, the 5 part, is between 1 and 10, so that looks okay, but the power of 10 needs to be a whole number, and 0.4 isn't a whole number. The only one that fits is this one here. 5's between 1 and 10, and minus 4 is just a negative whole number, so that's the one we need to be circling. Question 14. You can see in the title of this question, I'm going to give you two different methods. Two different methods, same result. We've got between 25 and 35 students in a class, we've been told. The ratio of boys to girls is 4 to 7, and we need to work out how many students are in the class. So I'm going to show you now what I've made previously, which is a table of values for boys and girls. So we can use this ratio here. So we've got boys, which is represented by the 4, and girls, which is represented by the number 7 in this ratio. And so if there were 4 boys, and if there were 7 girls, that would be a total of 4 plus 7, which would be 11 students. So, are there 11 students? Well, when you read the question, obviously not, because it's between 25 and 35. We just don't know how many. So, this is the question we need to ask ourselves now. And so, what could I multiply 11 by so that I'd have a number which is in between 25 and 35? Well, if in doubt, just try on your calculator. 11 times 2, would that be valid? That's too low. 22 is too low. But how about 11 multiplied by 3? 33. Now that is between 25 and 35, so that's great. So what we could do is multiply this total here by 3. But if we multiply this number here by 3, to keep the balance of the ratio, we need to do the same to the other components of the ratio as well. So we'll be doing 7 times 3 and 4 times 3. And so when we do this, 11 times 3, first of all, would be 33. Seven times 3, 21. 4 times 3 is 12. So you'd have 12 boys, 21 girls, which would be a total of 33 students. To be honest, we only asked what the total number of students is. We don't, strictly speaking, need to know how many boys and how many girls there are, but it just is nice to know anyway. So 12 boys, 21 girls, would be a total of 33 students. Method B. So same question 14, but a different method altogether. So there's between 25 and 35 students in a class, we're told. So they're whole numbers, you can't have half a student, and also they're quite small numbers. So small numbers and whole numbers, we can do a build-up method for these sorts of ratios. And so this is perhaps a slightly long-winded way of doing it, but this is an easier way of finding out how many students would be in the class. All we're told is that there's between 25 and 35 students. So we have a table of values here. We've got a ratio relating the girls to the boys. So boys is represented by the number of 4, and the number of girls is represented by the number 7. boys is mentioned first, then girls, just as the number 4 is mentioned first, then the 7. So boys 4, girls 7. In plain English, what does that mean? Well, it means that for every 4 boys, we've got, there'd be 7 girls. Total so far is 4 plus 7, which would be 11. Is that enough? No, it needs to be between 25 and 35. So again, what you can do is add another 4 boys, add another 7 girls. If you're thinking, why on earth is you doing these pictures and just faffing around like this? I'm not for a second saying I expect you to be drawing fancy pictures of little boys and little girls in silhouettes with bows on their heads like these little pictures have. That just takes too much time. What I'm saying is you could build it up like a tally chart. 4 boys, 7 girls. 4 boys, 7 girls. I'm just trying to be a bit prettier in terms of how I'm setting it out, hence the pictures. So 4 boys plus another 7 girls would be a total so far of 22. Again, not enough, so go again. Another 4 boys, another 7 girls. Keep going until you get a number which is between 25 and 35. So 1, 2, 3, 4 boys, and another 7 girls. 1 girl, 2, 3, 4, 5, 6, 7. If you're to add all those boys and girls up, that would be a total of 33, which is what we want. And so that's the question done as we need. So there'll be 33 students altogether in the class. Question 15, we have an inequality to solve. So I'll show you one way of doing it and then I'll show you another. So I'll just divide this screen into 2 separate parts for this one. So the main thing I'm going to say for all of these, for both options, is the fact that the inequality symbol can actually be treated as a equals sign. I'm not saying it's the same thing, it's not, but when you're solving inequalities, the inequality symbol can be thought of as an equals sign. So from now on, as we're solving this equation, I want you to think of it as 3x over 2 equals 9. So first of all, using this first method, to solve the equation, we want to have x on its own. And so this can be rearranged step by step. So the first thing we could do is move this 2 to the other side. That 2 at the bottom is dividing the whole top of the fraction. This means 3x divided by 2. When we swap the side of something, we swap its sign, we swap its operation, what it's doing. That 2's dividing, when it moves across, opposite of dividing is multiplying. The next step, on the left, we'll just have 3x, because that 2's moved across, that 2's moved to the 9 and multiplied it. 9 multiplied by 2 would be 18. The final step, we don't want 3x's, we want just 1x. 3x means 3 multiplied by x, so the 3 is a multiplier. If we swap the side and swap the sign, we'll change from a multiplying by 3 to dividing by 3. And so therefore, x will be 18 divided by 3, which equals 6. Now I did tell a little fib. The inequality isn't the same as an equals really, we can just treat it the same. So instead of the solution being x equals 6, we just put the inequality sign back in exactly the same way it was facing before. So the solution to this one is x, inequality symbol 6. Technically it means x is smaller than or equal to 6. But we don't really need to worry about the ins and outs of it. Second method, I'm going to show you how you can use a flowchart. This is an equation where all the x's are on the same side. So there's no x's over here. So what we can do is start with the thing we're trying to work out, in this case the x, and just ask step by step what happens to x. The first number it runs into is the 3, which multiplies it. After being multiplied by 3, we're going to divide by 2. And after dividing by 2, we'll have 9. Now what we can do is start at the end, and go the opposite way, doing the opposite things. So at this step above, we were dividing by 2, going the opposite way, we'll be multiplying by 2. We can make a little note of what the middle steps are. 9 times 2 gives us 18 so far, but we're not at the end yet, we still need to keep going. This way above, we were multiplying, going backwards, we'll be dividing by 3 instead. And so x will be 18 divided by 3, which is 6. And so x equals 6 if you like. But of course it wasn't really an equals sign, was it? It was x, then that symbol, and then 6. So 2 different ways of getting the same result, but that is the final answer. X, symbol, 6. Part B, we need to solve the inequality for brackets x plus 2 is greater than 12. Now yet again, we can think of this inequality symbol as like an equal sign. So if you think of it like this, the first thing we can do if we have brackets is expand them. So 4 multiplied by x and 4 multiplied by 2. 4 multiplied by x is 4x, and 4 multiplied by 2 would be 8. So 4x plus 8 equals 12. We want to have x on its own, and so what we can do, first of all, is we can move this 8 to the other side. But if we swap the side, we swap the sign. Opposite of adding 8 is subtract 8. And so 4x will equal 12 take away 8. 12 take away 8 is 4. Always use your calculator if you need to. You're allowed to in a calculator paper. 4x equals 4. And so x will have to be equal to 1. But again, if you want to follow procedure, that 4 is multiplying the x. If we swap the side, we'll swap the sign to a divide, because dividing is opposite to multiplying. So x will be 4 divided by 4, which is 1. X equals 4 divided by 4, which gives us 1. But of course, it wasn't really x equals 1. It was this inequality symbol. So to make sure you don't drop a mark, it's very easy to drop a mark. Always remember it was an inequality to begin with. So it wasn't really an equals sign. Put back the exact same symbol, the exact same way it was facing to begin with. Just going to show you how you can do this using the flowchart diagram method as well. So if you take this stage here and just copy it across to here. So expand your brackets out first. It's rarely a bad thing to expand brackets. So 4x plus 8 equals 12. So start with x, and step by step what happens to x. So the first thing that happens to x is it runs into the 4, which multiplies it. After being multiplied by 4, we add 8, and the outcome of all that is we end up with 12. Now we can start at the end and go the opposite way, doing the opposite things. So the opposite of adding 8 would be to take away 8. Opposite of multiplying by 4 is dividing by 4. So let's work this out step by step. And so 12 take away 8 would be 4 at this point, and then 4 divided by 4 would give us 1. And so again, x equals, in inverted commas, 1. But of course we know that was a little fib. X was never really equal to anything because of this inequality symbol. So x is greater than 1. Part C, we need to put these two bits together. Part C, it says represent the solution set that satisfies both answers to Part A and Part B. So let's remind ourselves what we had for Part A and Part B. So let's just go back and have a look. Part A, we had x was less than or equal to 6. And for Part B, we just did, we have x is greater than 1. And so the numbers we're interested in on this number line are going to be 6, which is here, and 1. Now what we're going to do on this number line is we're going to do a straight line between these two. But first of all, what we're going to do, we're going to just do circles above these two numbers. So a circle above 2 and a circle above 6. So x is going to be bigger than 1. I do apologise. What am I doing? X is bigger than 1. I've circled 2. I'm losing my mind. Apologies. So if you're staying with me for that mistake, I'll leave it in for the video for your own amusement. X is bigger than 1. Sorry about that. There we go. So like I was saying, we put a circle above each number. So x is bigger than 1, so x is somewhere along here, but x can't be bigger than 6. Once you've done the two circles, you then join them together with a straight line. And always do this line above the number line. So never do it below here. Always do this sort of diagram above. So the next thing is, we have a look at these symbols. Now, if it's an inequality with a line underneath, that means can also be equal to. And so if it's got one of these lines underneath it, what it means is above the number, which has this line underneath it, we make a filled in circle. A filled in circle represents that x could be equal to that number, as well as being less than it. This one here though, where x is bigger than 1, this one doesn't have one of those lines underneath it, and so we leave this as a hollow circle. The way I'd remember it is to ask yourself what requires more ink, either from your pen, or what requires more ink of a printer printing your exam paper. This symbol here with a line underneath, or a symbol without the line. Obviously this symbol requires more ink than that. So because this requires more ink, you fill it in. Because filling in a circle takes more ink from your pen than just drawing a hollow circle. A slightly strange way to remember it perhaps, but it always used to work for me. Now that's question 15 done for you. Question 16. We've got a question now about bearings. And so we've got Ali, Bayo, or is it Bao perhaps, and Carly. Start walking from P at the same time. At this point I'd like to just give thanks to Ali's, Bao's and Carly's parents for being so kind to have named their children with initials A, B and C. Because just by pure coincidence, A, B and C allows us to just label these quite easily. So that's very nice of their parents. Thank you very much for doing that for the sake of a maths exam question. Anyway, they start walking from P at the same time and they all walk at 4 miles an hour. So if you have a look here, for part A, we need to work out how long it takes Ali to walk 1 mile. For part A, the key bit of information is that they walk at 4 miles per hour. They all do. So that will include Ali. 4 miles an hour means by definition 4 miles in 1 hour. And because an hour's 60 minutes, that just means 4 miles in 60 minutes. But we're not interested in 4 miles, we want to work out how long it takes him to walk 1 mile. So the question is, how can we go from 4 miles down to just 1 mile? And so what can we divide 4 by to get 1? Well, the answer is any number divided by itself will give us 1. So we can divide the 4 by 4. 4 divided by 4 is 1, but if we do that to the mile side of the equation, we need to do it as well to the minute side of the relationship. So 60 divided by 4 will tell us how long it takes him to walk 1 mile. 60 divided by 4 will be 15 minutes. So each mile he walks will take him 15 minutes. So that's the answer to part A. Part B, I'm going to call him Bao. Bao says after 1 hour, Ali and Carly will have walked 4 miles each, because 4 plus 4 equals 8 miles, so they must be 8 miles apart. Is he correct? Well, without jumping into this question, let's just have a look at what information we've been given about all of these bearings. And so, if we have a look at Carly's first of all, I know Carly's mentioned last, but I think she's just as worthy of our attention. So Carly is on a bearing of 230. Bearings are always measured from north, clockwise. And so Carly's bearing, which we've been told is 230, is this angle I've highlighted in yellow on the diagram. So that's 230. The next one we can consider is Bao's. Now, Bao is represented by a B. So Bao's walking on a bearing of 165. And so for Bao, from north all the way to here will be 165 degrees. So if I just highlight this in green for Bao, we can say that's 165 degrees. And finally, we can do the same now for Ali. So Ali walks on a bearing of 75 degrees, we've been told. So what that means is, from here, from north until we face A for Ali, this will be a 75 degree bearing. So I'm just going to finish off my little highlighting task I've set myself. There we go. So now we can focus on what Bao is saying. So this would only be true if Ali and Carly are walking in exact opposite directions. So if we compare the directions for Ali and Carly, the difference between their directions is from here all the way to here. And so from A to C, is the bearing we need to work out. And so what that is if this is 75 and the whole thing from one to the other is 230, this one here will actually be 230 just without this initial first bit for A. So this will be 230 minus 75 which would be a bearing of, or an angle of, 155 degrees. So that means there's actually only 155 degrees between them. So in terms of ticking a box, they wouldn't be 8 miles apart, and the reason for the answer is that they are not walking in exactly opposite directions. If they were, it would be true, but because they're not, it's not going to be true. So that's going to be a no, because actually the bearing between them is 155 degrees rather than 180. So for part C now, we're asked who is closer to bow after 1 hour. So B for bow. So is it Ali or Carly? So what we can do here is just compare these two angles. So the angle between bow and Carly will be this one here. So to work out this one here, it'd be the whole 230 just without this green bit. So 230 take away 165. So 230 minus 165 equals 65 degrees. So the angle between bow and Carly is 65 degrees. Whereas we can then work out the angle between Ali and bow. So between Ali and bow is this green one here, 165, take away 75. So 165 take away 75 is 90 degrees. And so now you need to think about who's walking in a direction closer to bow. Carly's only 65 degrees away in terms of direction from bow, whereas Ali's walking away at a 90-degree angle from bow. And so because Carly's angle is closer to bow's than Ali's, Carly would actually be closer to bow. And so in terms of showing you working, this is the working shown. And we can say something simple like Carly's direction is closer to Bao's than Ali's is, because 65 degrees is smaller than 90. So you need to show these calculations to support your final answer. And that's question 16 done. Question 17, we've got a conversion question here. 1 mile equals 5,280 feet, 1 foot's 12 inches, 1 inch is 2.54 centimetres. So we need to use those conversions to show that 1 mile is approximately 1,600 metres. I've just rewrote all these conversions here. Nothing new, apart from what we've been given already. And what I want to draw your attention to is each one of these conversion relations is in the form where one number is a 1 and the other number isn't 1. So 1 mile, 5,280 feet. 1 foot, 12 inches, and 1 inch, 2.54 centimetres. The reason I'm emphasising the 1 and the other number is if a relationship is ever in this form, where one number is 1, the other number isn't 1, we can always change from one to the other by multiplying or dividing by the number that isn't 1. So in this case, miles and feet, the number that isn't 1 is 5,280. So if we were changing from miles to feet, we're going from a smaller number to a bigger number. So we'd be multiplying by 5,280. If we're going the opposite way round, if we were going from feet back to miles, instead of multiplying by 5,280, we'd be dividing by 5,280. So that's how we can change from miles to feet. And in the same way, these other relationships work in the same way as well. 1 foot, 12 inches. This one as well, we've got a number which is a 1, a number that isn't 1. So for feet and inches, to change from one to the other, we're going to be multiplying or dividing by the number that isn't 1, which is the 12, as in 12 inches. To change from feet to inches, going from a small number to a big number, so we'll be multiplying by 12. Going the other way, therefore, from inches to feet, going from a big number, 12, and making it smaller, so we'll be dividing by 12. And exactly the same idea for inches and centimetres. Inch to centimetre, we're going to times by 2.54. Going the other way around, from centimetres to inches, we'll be dividing by 2.54. So before we get started, I just thought I'd mention and emphasise how to convert from one to the other for these different conversion factors. So first of all, we've been given 1 mile. So 1 mile we can change using the conversion factor for miles we've been given. So 1 mile we can change to feet by multiplying it by 5,280. From miles to feet we're going to multiply. So multiply by 5,280 and we get 5,280 feet. So 1 mile is 5,280 feet. Now we've got an answer in feet, we can change it into inches. 1 foot to inches we multiply by 12. So we can take the number of feet a mile is, which is 5,280, and multiply it by 12 to change it into inches. So for this calculation now, 5,280 multiplied by 12 gives us 63,360. Inches. That's a lot of inches. And finally, we've got a conversion factor down here for changing inches to centimetres. From inches to centimetres, we're going to multiply by 2.54. And so we can take our number of inches, which is this huge number here, 63,000 and whatever, and multiply it by 2.54, and that'll tell us what a mile is in terms of centimetres. So 63,360 multiplied by 2.54 would give us 160,934.4 centimetres. Now, there is one conversion factor missing that hasn't been included. We want the answer in metres. So one thing we need is to be able to change from metres to centimetres. So there's no getting away from needing to know how many centimetres make a metre, and the answer to that is 100. And again, look at this. Again, it's in the relationship where one number is a 1, the other number isn't 1. So yet again, what we can do is either multiply or divide by the number that isn't the 1. In this case, it's the 100. So to change from metres to centimetres, we'd be multiplying by 100, because we're going from a smaller number to a bigger number. And going the other way around, from centimetres changing to metres, opposite of timesing by 100 is dividing by 100. And so finally, we can change our answer in centimetres to an answer in metres by dividing this amount by 100. So if we take this figure here and divide it by 100, we get 1609.344. So 1609.344 metres. And that's what 1 mile equals. So that's 1600 metres and an extra 9.344. So that's very close to 1600 metres as we needed to prove. So that shows us quite neatly that 1 mile is very close to 1600 metres. In fact, it's a tiny bit over. Question 18. Solve x squared equals 30.25. Now, if nothing else, Pythagoras should have taught you to go from something squared to just what the number is on its own. We take the square root. And so x may well be the square root of 30.25. So we can do this easily enough on the calculator. Square root of 30.25 gives us 5.5. I said x may be the square root rather than x is the square root, because what you should hopefully remember is that when we square a positive number multiplied by a positive number gives us, obviously, a positive number. But there's also an often forgotten other alternative. Perhaps both numbers are negative. And so with Pythagoras, we only consider the positive value for a side length, because obviously the length of a triangle has to be positive. You can't have a negative length of something. But because x could be either positive or negative, the answer is either 5.5 or its minus counterpart. So always include 5.5 or minus 5.5. For example, if x squared was 36, x would be 6 or minus 6. You need to give two of these options. You need to give both a positive and negative solution rather than just the positive. You'd lose a mark if you just put 5.5. Question 19, we've got cola, which is sold in different packs, packs of 6 and packs of 8. And the different packs each have special offers. And so 2 packs of 6 for £3.50. If you buy them with packs of 6, Or packs of 8 come in their own offer, 2 packs of 8 for £5. So what we need to do is work out the cheapest way to buy 48 cans of cola. So whether you're buying packs of 6 or packs of 12, hopefully you can see that the offer is better value than just buying single packs. One pack of 6 is £1.95. At that rate, 2 packs of 6 would be 2 times £1.95, which should be £3.90. Similar with this one as well. So we're going to try and maximise how many offers we can use. So I've just divided the screen into 2 different sections here. So I'm going to talk of packs of 6 first. So packs of 6 up here. So using this offer, 2 packs of 6 we can get for £3.50. Now 2 packs of 6 would be 12 cans altogether, because 2 times 6 is 12. What we want though is 48 cans of cola. So if we were buying packs of 6, we could get exactly 48, because 12 fits into 48 exactly. And so how could we go from 12 to 48? So to go from 12 to 48, we could multiply by 4. So if you multiply these by 4, instead of getting 2 packs of 6, 2 times 4, we could get 8 packs of 6, basically using this offer 4 times. So for 2 packs of 6 for £3.50 offer, we could use that 4 times. 2 packs times 4 would be 8 packs of 6, and £3.50 multiplied by 4, with a calculator or without, £3.50 multiplied by 4 would give us £14. And so buying packs of 6, we could buy 48 cans exactly by getting 8 6-packs. 8 times 6 is 48 cans, and that'd be £14. So that's packs of 6. We can now try and work out for packs of 8. So the offer for packs of 8 is we can buy 2 packs of 8 for £5. That's worth just thinking, how much would 2 packs of 8 be? 2 packs of 8 would be an 8-pack plus another 8-pack. That'd be 16 cans of cola altogether. Again though, we're interested in buying 48 cans as cheaply as we can. So how many lots of 16 would we need to get 48? Again, if you're not sure, we can always just do a division. 48 divided by 16 is 3. So what that means is we need 3 times as much as the 2 packs of 8 offer. And so what we can do, in effect, is use this 2 packs of 8 offer 3 times. So instead of getting 2 packs of 8, we could get 6 packs of 8. And if we use this offer 3 times, then the price for using this offer 3 times would be the offer price of £5 multiplied by 3 as well. So 5 multiplied by 3 comes out to be 15. And so if we use the packs of 8, we could get 48 cans for £15. Or using the packs of 6, we can get 8 packs of 6 for £14. And so we need to do working for both packs of 6 and packs of 8, so we can then see correctly that the packs of 6 offer will be cheaper by £1. And so this is the working we need to back up the final conclusion, and the answer of the cheapest way to buy 48 cans is if we buy 8 packs of 6. You can't just put that down without any working. You need all this working and then this final conclusion based on that correct working. Question 20. Got two piles of the same type of paper. Each sheet of paper is 7/1000ths of a centimetre thick. And we're told that the taller pile is 10.5 centimetres high. And so how many of those little bits of paper would you need to stack up to get to 10.5? This question is essentially how many of a little thing, in this case the thickness of paper, how many of a little thing would you need to get to this bigger number? This is going to be a fitting question, which is a division. So we could calculate how many pieces of paper are in this 10.5 centimetre stack by doing 10.5 divided by the thickness of each sheet. So the calculation we need to do is 10.5 divided by 7/1000. Now this is a hard calculation in itself for a calculator, so just pay attention when I show you how to do this on a calculator. 10.5 needs to be typed in a certain way, so we can't just do 10 then use a fraction button to put a half. There's actually a button on a calculator here for doing mixed numbers. And so on a Casio calculator like this, it'd be Shift, then the fraction button. Then type in 10 first for the whole number part, and the fraction part of a mixed number we can type in after. So 10.5. I'm going to divide that by this fraction here, which should be 7/1000ths. So typing that in on a calculator takes a bit of understanding in itself. If you press equals, we get 1,500. So that means it was 1,500 sheets in the 10.5 centimetre stack of paper. We've also got a ratio now we can consider. We've got height of a taller pile as a ratio to the height of a shorter pile, which is 3:2. And so what we've done here though is we've actually worked out how many sheets are in the taller pile. The taller pile, there's 1,500 sheets. And so that 3 represents 1,500. And 1,500 is obviously bigger than 3. But how many times bigger than 3 is 1,500? So what we can do is try and work out what we need to multiply 3 by to get 1,500. Essentially working out how much each lot of paper is worth. You can think of this as being 3 lots to 2 lots. So 3 lots is 1,500. Each lot of paper, each ratio share, would be 500. And so you can think of this as being 3 lots of 500, which gives us the 1,500. And so for the shorter pile now, if one lot is 500, then 2 lots of 500 will be 1,000. Or you can think of it as what you do to one side of the ratio, we do to the other. So 2 times 500 would be 1,000. So the number of sheets in the shorter pile would be 1,000. Quite a tricky question, that one, but there we have our answer to it. Got 1,000 sheets in the shorter pile. Question 21. we're asked which two triangles are congruent. Congruent is just a fancy word you might see on the maths paper, and all it means is identical. So which two triangles are identical is what this question is asking us. Now there is a test for triangle congruency, and one thing we can test for triangle congruency is if we have an angle trapped in between two sides and the angle's the same and the two sides trapping the angle is also the same. So in this case, for example looking at B, we've got a 5 centimetre line and a 3 centimetre line coming together to make a 30-degree angle. And we have the same thing with C as well, because that's a 5 centimetre line and a 3 centimetre line which are together and form a 30-degree angle where they meet. What this is called, sorry, that's B and C. So B and C are the ones we need to circle. These are the two triangles that are identical to each other. Triangle B and triangle C. And what we've done to prove that these two are identical is we use the fact that each one has got a side of 5 and a side of 3 and an angle of 30 degrees in between. So two sides with an angle between. What this means is it's side, angle, side. So because we've got a side which is the same, trapping an angle which is the same in both, and then the next side is also the same in both, SAS is what we've used to prove that these two triangles are equal. So side, angle, side is the congruency fact we've used here, SAS 533. Question 22, we've been given a formula for the volume of a sphere, which is 4/3 pi r cubed, where r is the radius. And so what we need to do here is work out the volume of a sphere of radius 8 centimetres. And so I've been told already what the radius is. The radius is 8, and it says here r is the radius. Now this formula has no mathematical instructions between each thing. So in maths or algebra, if there's no instruction saying what's happening between different things, it will always mean they're being multiplied by each other. So this means that the volume is 4/3 multiplied by pi multiplied by the radius cubed, which in this case is 8 cubed, because the question says that the radius is 8. So what we need to do now is to just process this on our calculator. So with a good calculator, you should be able to type this in exactly as it appears. So 4/3 multiplied by pi. Now on this calculator, we press Shift and then the pi button. Now pi is 3.142 if you want to use a numerical figure for pi, but it's probably easier and more accurate to use your pi button on the calculator. Anyway, 4/3 multiplied by pi multiplied by the radius, which is 8 cubed, 8 to the power 3. Press equals. We'll get an answer in terms of pi. What we need for this question is a numerical answer, so press this button here to convert it into decimal form, and we get 2144.660585. It doesn't say in this question what to round our answer to. If you're really not sure, just write down what the calculator says. I'm going to show you now though how you can round this off to one decimal place, which might be a bit more sensible. So 2144 is the whole number part, and the decimal part of this number starts as a 6, so if we want to keep one number after the decimal, that 6 will either stay as it is or it might round up to a 7. The way we would decide is we look at the number next to that 6, which is another 6. So this is the deciding digit. If the deciding digit is 5 or more, what we do is we round up. So to one decimal place, for example, this one would be 2144.7 cubic centimetres. You could have, I suppose, rounded it as well to the nearest whole number, which would have been 2145. As long as your rounding is sensible and you're comfortable rounding, you can round it. If in doubt, just put what your calculator says if you're not sure what to round it to, or if a question also says doesn't say what to round to. Part B, we've got this new diagram, and we're told that 3 spheres of radius 8 centimetres are packed tightly into a cuboid, as shown here. And so, again, the radius is 8, so it's the same sort of spheres. Now, the radius of a sphere just means the distance from the middle to the outside. And so, this means the radius would be 8. But what I could do with knowing isn't just the radius, we could do with knowing the diameter. Now the diameter is all the way from one end to the other. In the same way the diameter of a circle is all the way from one end to the other, going through the centre. It's the same for a sphere as well. So I'll just write that down, just so you're clear, that the diameter is always the radius multiplied by 2. So in this case, the radius is 8. 8 times 2 tells us that the diameter is 16 centimetres. So for each one of these spheres, the diameter, all the way from one end to the other, is 16 centimetres. And so from that, what we can do is we can work out the total length of this cuboid. So the diameter is 16, which I'll just highlight here. That tells us that each one of these spheres is 16 along. So that's 16 centimetres. That's 16. And that's 16. 3 spheres, 3 lots of 16. And so from this we can work out the total length of this cuboid. So from one end to the other, it'll be 16 plus 16 plus 16, which is essentially just 16 multiplied by 3. 16 multiplied by 3 is 48. And so the length of this cuboid is 48 centimetres. Now, there's only 3 spheres, and so there's a row of 3, so the width will just be the width of one sphere. So again, from end to end, these spheres are 16, and so the width of this box, the width of this cuboid, must be 16 centimetres, which is the same as the diameter of these spheres. And again, the height must also be 16, because they're touching the tops and touching the bottoms. So all the way from top to bottom, which is the same as all the way from side to side, means the height of this box must also be worth 16. Let's put 16 here, which again is because that's the diameter. So we now know that the length of the cuboid is 48. We know what the width of it is. The width of it is 16. And the height of it, again, is 16. Now the volume of a cuboid has a fairly simple formula. And the volume of a cuboid is the length multiplied by the width multiplied by the height. Length times width times height. And we've worked out these figures already. So the length is 48. The width was 16. And again, the height is also 16. 48 times 16 times 16. That will tell us the volume of a cuboid. So 48 times 16 times 16 gives us 12288. Cubic centimeters. And that's our answer for the volume of this cuboid. Question 23, the last question. Describe fully the single transformation that maps triangle A to triangle B. That's important in itself. We're not going from B to A, we're going from A to B. And so from A to B, the triangle's actually got smaller. So there's only 4 types of transformation it could be. So is it a rotation? Has a shape been rotated? No, it's still the same way up. It's still facing in the same direction. Has it been reflected? Is it a reflection? Again, the answer to that would be no. A translation is when it doesn't change size or shape, it just moves. Unfortunately, it has changed size, so it's not just a translation. It would therefore be a rotation. Sorry, it would therefore be an enlargement. So we need to say it's an enlargement. So because it's an enlargement, I'll just put it this here. There's only ever 4 types of transformation you'll be asked. It is an enlargement. So your first mark, just say the word, just write down the word enlargement. The second mark will be for saying the scale factor of the enlargement. Now this one here, the triangle's actually got smaller. It's gone from a bigger triangle to a smaller one. A scale factor can be calculated like this. It's the length of the new side divided by the length of the old side. Now the 2 sides need to correspond. And so what I would suggest is the easiest side to pick would be the bottom edge. So the new side, the new shape is B. So this one is just 1 square along. But on the original shape, the length of the original longer side, if we have a look at this one, it used to be all the way from here to here. It used to be 3 squares along. So it was 3, it shrunk down to just 1. So it's a fractional enlargement. It's 1/3 the size it used to be. So the scale factor for your second mark is 1/3. If the scale factor is a fraction less than 1, that's how you represent a shrinking of a shape. So weirdly, it's still an enlargement, even though the shape's got smaller. It's an enlargement scale factor 1/3. If it was an enlargement from B to A, the scale factor would have been 3, but because it's shrunk, the scale factor is actually 1/3. The final mark is we need to find the centre of enlargement. And what you'll need for this one is a ruler. What we're going to do, we're going to draw a straight line through each point and its corresponding initial point. And so if we do a line from this point going through this one and carried on, it'll go through this point here. Through the right angle, through the smaller right angle and the smaller shape, and carry it on. And finally that third point, through this point and carry it on, what you'll find is that the points will converge, the lines will converge at a certain point. The point where all the lines meet is the centre of enlargement. So the centre of enlargement here is the origin. So you could either just say the origin, or you could say 0, 0, which is the coordinates of the origin. So that's 3 marks. 1 mark, enlargement. 2nd mark, say the scale factor is 1/3. 3rd mark, centre of enlargement is 0, 0. And that completes question 23, and for that matter, the entire paper. So I hope you found some of those questions useful to go through. Again, do have a look through the other ones which were hard, and feel free to have a look at the other videos as well on this channel. Feel free to leave a comment, either a positive or negative one, and let me know if you need anything else, maybe just explaining in a different way, or any question that wasn't too clear, let me know. I'll do my best to explain it to you in the comments. Thanks for watching, and I'll see you again soon.